And I'll be working some example problems off of worksheet 4-2. Starting with example 1. We want to use the graph of each of these quadratic equations to determine its solutions. The solutions of the graph, also known as its roots, also known as its zeros, also known as its x-intercepts. So where the parabola meets the x-axis is going to determine the solution to the equation. So this parabola meets the x-axis at -1 and at +1. So those will be my solutions, x equals 1 and x equals -1. On problem number 2, this parabola does not reach the x-axis. It turns around before it gets there. And in that situation, since it has no x-intercepts, it will also have no solutions. We look at number 4. We have this quadratic that we want to graph. And so what I'm going to do is take it and instead of equals 0, I'm put it equal to y. I'm going to put it in y1 in my calculator. So once I've put it in the calculator, then I can look at my table of values, second graph, and decide what points are going to actually fit on the graph that they provided me. -4, -3, -3, 5, -2, 9, -1, 9, 0, 5. I think most of those will fit. Fortunately, -1, 9 and -2, 9 will be off my screen a little bit, but I'm not interested in the vertex. I'm interested in the x-intercepts. The x-intercepts will be here and here. Unfortunately, those are not integer values, and so I'm asked to state the consecutive integers between where the x-intercepts or where the roots or solutions are located. So x is between -4 and -3, and x is between 0 and 1. I guess it's technically between would be strictly less than in both cases. Moving on to worksheet 4-3. If I want to write the quadratic equation in standard form for these roots, then I would take the two roots, 7 and 2, and create two binomials of x minus 7 and x minus 2 equals 0. Then I would FOIL. X times x is x squared. X times -2 would be -2x. -7 times x is -7x. And -7 times -2 will be a +14, still equal to 0. And then my last step, I'll combine the two like terms in the middle for one equation of x squared minus 9x plus 14 equals 0. And number 2, do the same thing, except it turns out a little bit different because it's a 0. X minus 0 times x minus 3 turns into x minus 0 is just x, and x minus 3. So when I distribute, instead of FOIL, it's x squared minus 3x equals 0. Numbers 10 through 15, we're asked to factor each polynomial. When we're factoring, first thing we need to look for greatest common factor? If there is one, we'll divide it out. Second thing to look for is it a difference of two squares? And if it's not, the third thing we'll do is we'll try to factor using the box method. So looking at number 10, look for a greatest common factor, and I see that all of the terms have r as a factor. So I divide r off of every term. I get r squared plus 3r minus 54. So then I look at my trinomial in the middle, and it's not a difference of two squares, so I'm going to try the box method. Box method goes something like this. This term goes here, the last term is here, and then I need these two terms to add together to give me 3r. So, and this is going to be a multiplication box, so what times what can give me r squared? It's probably going to be r times r. And then for 54, I need two numbers that will multiply together to give me negative 54. Probably 9 and 6, and we need to make one of them negative. Since my total needs to be a positive 3r, I'm going to make the smaller one negative and leave the larger one positive so that my result will be positive. So let's see what I get when I multiply r. First row, first column, or first row, second column would become negative 6r, and then 9 times r is 9r, and those add together to give me 3r. So then that means that this polynomial breaks down into r times r minus 6 times r plus 9. Looking at number 12, do they have a greatest common factor? No. Are they a difference of two squares? What that means is there a perfect square root of c squared? Yes. Is there a perfect square root of 49? Yes. Are they being subtracted? Yes. So that means that this can break down into the binomials c and c being the square root of c squared, and the square root of 49 is 7, so 7 and 7. One will be a positive, one will be plus, c plus 7, one will be c minus 7. We go to 15. Is b to the fourth a perfect square? I don't know. What is the square root of b to the fourth? It would be b squared. What is the square root of 81? Well, that would be 9. So then that means that this does break down as a difference of two squares as b squared plus 9 and b squared minus 9. But am I finished? Look here, b squared minus 9, I have a difference of two squares again. So b squared minus 9 can be broken up as b plus 3 and b minus 3. And I leave b squared plus 9. If it's a sum of two squares, it can't be broken down. But a difference of two squares can. Finally, get to the full scale of where we need to solve each equation by factoring as opposed to by graphing. You can still check through graphing that your solutions are right, but you need to show your work through factoring. So the first thing I need to look for is a greatest common factor. There is none. So the next thing I look, is it a difference of 2 squares? No, it's a trinomial. So then the next thing I do is create my box and factor this. This will be the x squared, this will be the negative 12, and these two need to add up to negative 4x. To get x squared, it'll be x and x. And then to get negative 12, I need two numbers that multiply together to give me negative 12. But when they add together, they give me negative 4. So we're looking at 6 and 2, with the 6 being the negative one and the 2 being the positive one. 2 times 6 is negative 12. 2 times negative 6 is negative 12. And 2 minus 6 is negative 4. So when I fill in the squares that are empty, that becomes a negative 6x and a 2x, which, yes, those two will add together to give me negative 4x. So that means that this broke down into what I have at the top, what I have here on the side. X plus 2 and x minus 6 equal to 0. As we learned before, if I have two things that multiply together to give me 0, then either x plus 2 has to be 0 or x minus 6 has to be 0, which leads to my two solutions, or two roots. Subtract 2 from both sides on this one. X would be negative 2, or add 6 to both sides. X is positive 6. So that is the solved equation. Those are the roots, those are solutions. Let's look at number 21. First thing we have to do is make sure we get set it equal to 0. So 7x squared minus 4x equals 0. Then we can start looking for how to factor. Is there a greatest common factor? Yes. Both have x as a factor. So that breaks down. After you divide out the x, you get 7x minus 4 equals 0. Now I have two things again multiplied together to give me 0, which means either x is 0 or 7x minus 4 is 0. That I don't have to break down any farther. On this side, add 4 to both sides. 7x equals 4 divided by 7. X would be 4 over 7. So those are my two roots. Last one we'll look at is number 26. 36x squared equals 25. Again, I need to set it equal to 0. 36x squared minus 25 equals 0. So I look and see, do they have anything in common? Is there a greatest common factor? No, nothing goes into 36 and 25. So then I look and see, is there a difference? Are both of these perfect squares? Is 36x squared a perfect square? Well, yes, that comes out to 6x. Is 25 a perfect square? Yes, it's 5. Square root of that is 5. So that means I can break this up into 6x plus 5 times 6x minus 5. Still equal to 0. Which means if I have two things multiplied together to give me 0, one of them has to be 0. Either 6x plus 5 is 0, or 6x minus 5 equals 0. So when on this first equation, I subtract 5 and divide by 6, x will be negative 5 over 6. On this equation, I'm going to add 5 and divide by 6, so x will be a positive 5 over 6. So those will be my two solutions. We'll do one more, number 28. Two consecutive even positive integers whose product is 624. Okay, how do we create an equation that will give me two consecutive even positive integers? Well, let's say the first one is x. Let's just say that x is an even positive integer. How do I find the next even positive integer? Well, I'll have to add 2. Because if x is 2, then the next one will be 4. 2 plus 2 is 4. Now their product has to be 624. Okay? Well, let's FOIL this, because I have to set it equal to 0. So, well, I can do this. X times x plus 2 minus 624 equals 0. Which means x squared plus 2x minus 624 equals 0. Do they have anything in common? No. There's 2 squares? No. So let's box method. I need 2 numbers that multiply together to give me negative 624. And they add together to give me 2x. So let's explore the factors of 624. I need 2 numbers that multiply together. They multiply together to give me negative 624, and they add together to give me 2. So let's experiment on our calculator. 624 divided by 2 is 312. Okay? So that's not going to get me very close. 2 times 312, that's too far apart. All right, so let's see, what if I divide by 624 divided by, what goes into, let's say 80, nope, 8, what's 8? Nope, 624 divided by 8, just 8. There we go, 78 times 8. Right? What's a factor of 78? What goes into 78 evenly? 2. So let's try 16. So let's try 624 divided by 16. There's 39. 39 is divisible by 3. What's 3 times 16? 48. So what's 624 divided by 48? We're still too far apart. So let's look for some numbers that multiply together to give me 624. We're still trying to figure out. What about 624 divided by 26? There we go. 26 times 24 equals 624. And 26 and 24 are 2 apart. So what that means is if I'm trying to get it to equal negative 624 and add together to give me 2. So 26 times 24, that means 26 and 24. It's going to be x and x. This will be the negative. This will be the positive. Negative 24 times 26 will give me negative 624. X times 26 will be 26x. This x times this negative 24, negative 24x, and that'll add up to give me 2x. So that means that, I could go down here, that this factors into x minus 24 and x plus 26 equals 0, which means x minus 24 is 0, or x plus 26 is 0. Add 24 to both sides means x is either 24 or x is either negative 26. But we were told that x has to be a positive number. That means that's my positive number. So the 2 consecutive integers are 24 and positive 26.